Hello, hello. I am here. Sorry, I'm actually over here. This is just a quick thing about how to do IR. I'm going to share a few details and we're going to look at some Master Organic Chemistry tutor tips because he's probably better at explaining this than I am, and I'm just kind of showing it to you because I'm around, you know what I mean? You could probably get it off of just this, but hopefully it's a bit easier to understand if I say something to add it up. So, Mach, he gives you, you have your general regions that you know your NH, you know your OH, alkenes, alkynes, nitrile groups, your ketone group. You These are more categorized. They're categorized a bit better, so they're a bit easier to understand. He makes this distinction of tongues versus swords. So when people say broad peaks, that's what they mean. Tongues. Tongues are broad peaks. So alcohol, which these are examples of here, these alcohols, and one of these might be a carboxylic acid, but no, these are all alcohols. These alcohol stretches, this is what they mean when they say broad, strong peak. These down here, these sharp peaks, when they say sharp, this is what they mean. So when I say there's a sharp peak in ether, here. When I say there's a broad alcohol peak, here. Strong difference. This guy uses a method, and it's pretty much the 1 minute look warning. Is kind of how you describe it. You look for five things. So you look for alcohols and carboxylic acids, right? Boom. So this is an example of an alcohol. These are alkane peaks, or if they cross a bit over 3,000, they're alkyne and alkane peaks, but they're alkane peaks. This broad and wide peak that kind of starts and branches out past 3,300 and goes deep, like it's past 3,000, it goes past 3,000 back and past 3,000 forward. These are carboxylic acid peaks. These are the So you look for these two first. If you don't see them, you cross that off the list. Then you go to these groups. Aldehydes, important. 1740 to 1690. Ketones. And you're like, wait, aldehydes and ketones overlap. It's almost like aldehydes and ketones are very similar. You're correct. Stupid piece of shit. Sorry. You're correct. They do overlap because they are kind of similar. Esters overlap. Carboxylic acids have a secondary peak that will be in this region. Amides have a peak that's below 1690. And anhydrides, which are pretty much they're pretty much ketones or dicarboxylic acids or diesters, is what you could call them, are in this range. There's normally going to be two peaks. This covers CH. So remember how I said if it goes a bit past 3,000, you can know it's an ene. If it goes a bit past 3,000, it's easy to tell it's an ene. If it's all above 3,000, it's a ring. If it's below 3,000, it's normally sp3. It's an alkane. Triple bonds have a few variety peaks. I never look for these. In my opinion, I think they're very hard to tell, and sometimes it's just an interference from your IR. Especially when you do this in the lab, you'll see what I mean when I say at 2,000 there could be a lot of things that show a small peak here. That when they're talking about butane and hexine, benzonitrile and propyl nitriles will have a peak here. But as you can see with these nitriles, even these small peaks I normally just ignore unless it's like the only thing you have, which I have a few IRs that are pretty bad. But so when I say we're stepping it out, we have you look for alcohol carboxylic acid, you look for these functional groups because they're the easiest to determine. and then everything else you pretty much ignore. Anything that goes into the fingerprint, you don't look for. Fingerprint doesn't matter. It's a fingerprint for a reason. So let's do a few practice questions to see if we can make some sense of this. All right, y'all ready? This is what I'm going to call the 1 minute warning. We're going to run this through as fast as possible and try and get each of these questions done in about 1 minute. So let me check my time. 10 seconds in. Let's get started. 1 minute. So, first things first. What does that peak tell us? This is likely got an alcohol in it. That's actually pretty much completely indicative of an alcohol. It's not broad enough to be a carboxylic acid. And it doesn't look like an amine peak. And we know our chemical formula. We don't have an amine. It's got to have an alcohol in it. So, remove, remove, remove. Now, we see SP3 here in this peak. This peak is the SP3 peak that we were talking about earlier. So we can see that. Now, we know it's got to have an alcohol. We shouldn't show anything in this range if it's an alcohol. So now we have to ask ourselves some structural questions. C5H10. Now, when they give you the chemical formula and structures, you can do this now. We know that C5 should have at least, C5 should have at least, what do you call it? We're at 1 minute. Should have at least 12 hydrogens. So it means it's unsaturated to an extent. And we know that one of these hydrogens that are actually in the equation has to be bound to one of the oxygen to make an alcohol. So, if we look at these, we need a degree of unsaturation. How unsaturated is this? This does not have enough unsaturation to make our compound. Because if we count, that's 3. So over here, 7. That's 8. 8, 9, 11, 12. That doesn't meet what we need. It's got to be E. Whew. So that's question 1. Let's run to question 2. Let's run it up. Okay. Delete. Upload. Problem, IR2, open. Now we're looking at question 2. We're at 2 minutes 40 seconds, so let's do this pretty quick. What do we see? We don't see an alcohol peak. So what does that mean? We can eliminate our alcohols. Eliminate alcohol. Eliminate alcohol. No alcohol peak, no carboxylic acid peak. We only see alkanes here. So we have a nice alkane peak, and this is an ether. Yeah, it's an ether. This is an ester. This is a ketone. Esters can show a peak here, right? Ethers do not show any peaks in this region, so it's not an ether. So what we can look at now is between ester and ketone. Now we count structure. C6H12. So we go 3, 5, 7, 3, 5, 7. Okay, yeah, 3, 5, 7, 9 plus 3, that's 12. That fits. Now we go here. 2, 4, 6, 8. Which one meets it? D meets it. You don't have enough hydrogens in our... Also, we don't have enough oxygens. That's why it can't be C either. We don't have enough oxygens for it to be an an ester either. That one should have stuck out to me more. But hey, we made that one in pretty good time. Let's step it out. Next one. Okay, before I scroll through my images anymore, let me just type it in. Boom. Now, we have another lack of an alcohol. No alcohol, no alcohol, no alcohol, no alcohol. Get the hell out of here. No alcohol. We don't have a super strong peak showing any of these three. So we honestly should just eliminate the... We honestly could just eliminate the... I think it has too many hydrogens. But now it's time... So we know it's not an alcohol. We know it's an alkane. Now it's time to count. I hate counting. I hope you learn to hate it as much as I do. 3. So that's 3, 5, 7, 9, 11, 14. This is 614. I know it looks bad. The resolution's bad. I don't know why, but when I copy these images, they copy like dog shit. 14. What do you call it? That's fine. That's the correct number of oxygens, correct number of hydrogens. So we go here. 1, 3, 5, 7, 9. I might have miscounted. Oh wait, 9. Yeah, plus 3. 9 plus 3 is 12. What the hell am I doing? Can't be D. 3. Yeah, we go 3, 5, 1, 2, 6. That's 6. Plus 7. That's 7. 7 plus 2, which is 9. That's also... So it can't be E or D because we counted. We look, it's C. That's the only one that can match on chemical formula, and it's the only one that has the same functional groups. So this time it's an ether. That's D. Now we cook. We erase those. Last question. Last question. Delete. Browse your computer. Problem 4ir.jpg. Last one. This one's a bit harder. But what do we see here? This big broad-ass peak. That's a carb box acid. It's an acid. It's a carboxylic acid. It can't be. So it can't be an ester. Yeah. Let me erase that real quick. It's a carboxylic acid. It's not an alcohol. That's like not a carboxylic acid. That's like a... It's not this. Yeah, that's not a carboxylic acid. This is a carboxylic acid. This isn't a carboxylic acid. And I don't think this is either. Yeah, because it's not double bond. It's not a double bonded oxygen. Yeah, that's not carboxylic acid either. Our key point, not a if it's got that, it's carboxylic acid. Everything else you kind of know, and it's B. All of these are correct. I'm just checking. It should be B. Let me just triple check. It's B. The answer is B. Boom. But simple breakdown of what we do. All you have to do with IR is identify functional groups. There's 2 steps to identifying functional groups. Never look below this line. Once you start getting into the thousands, you're looking for trouble. Nothing here is very identifiable. Look for the big stuff. So look for alcohols, carboxylic acids. Carboxylic acids are wider than alcohol. Then look for esters. Okay, yeah, look for esters, aldehydes, ketones. Look for esters, aldehydes, ketones. You might find alkyl halides, nitriles, stuff like that. But look for stuff that's easy to identify. So let me go back here. And he has a list of stuff that's easy to identify on this website. And I'm going to probably put the link to this in the description. Aldehydes, ketones, esters, amides, and anhydrides. Carboxylic acids will also have secondary peaks. But everything in this range, oh my god, that's like everything over here. You can look at once you've identified, do you have an alkane, an alkyne, a carboxylic acid, a whatever the hell in the high 3000 range. You look at that. Then you go down, look for key players. Once you have key players, then you check your formula, then you check your structure. Now, there is another website I have to show you. It's called Web Spectra. If you've come in person, I've probably tried to do some of these problems with you. Problem with Web Spectra is, right, Web Spectra isn't designed for teaching you IR. Because they give you the chemical name, but they don't give you a structure to compare to. They don't give you anything. The reason Web Spectra is much rougher is because they have NMR. Now, while IR tells you functional groups, right? NMR, these peaks, will tell you structure. They'll tell you how to put together the atom. So with the functional groups, with the structure, with these, you can build this entire molecule. But IR can only tell you have an alcohol here, right? It can only tell you that you have an alcohol and that you might have a ketone, or if you have an alcohol or an ester or a ketone. And when you look at it, it's an alcohol and it's actually an ether. Methoxy is ether. Methoxy is how you would say an ether group. But that's why when you start looking at Web Spectra, it's a 50-50. I didn't think about this before, but since you guys don't know how to do NMR, it's probably really hard for you to use Web Spectra. But I hope if you want to look at this website and if you want to run a few more of his practice problems, you have a good time doing it, because these are pretty good spectra to practice. Hey, have a good one. Bye-bye.